Today we wish to discuss the topic of nutrient recovery. This involves the reclamation of nitrogen, phosphorus, and potassium. In an effort to understand some of the key fundamentals that drive the waste and recycling industry, we have developed a website, waste.net, to act as a tool to assist in grasping the 4R strategy of reduce, reuse, recycle, and recover. Within the 4R's recovery sector, a key objective is the reclamation of various elements. Within the wastewater circuit, the concentration and selective extraction of materials, such as mineral salts and nutrients, are just some of the items included in our goals. Nutrients, primarily nitrogen with the chemical symbol N, phosphorus with the chemical symbol P, along with potassium with the chemical symbol K, accumulate in wastewater due to the intentional or unintentional disposal of organic matter, fertilizers, detergents and industrial waste into sewage systems. These nutrients are concentrated in wastewater because they are essential components of human food. They also come from the residues of cleaning agents and from agricultural production processes. Domestic sewage is high in nitrogen and phosphorus because food, which is a key source of these nutrients, is metabolized and excreted by humans. Domestic and industrial wastewater is also a pathway for the disposal of detergents, soaps, and cleaning products. These household and industrial cleaning agents often contain high levels of phosphate detergents. Nutrients from animal manure accumulate in both solids and liquid wastewater, but the specific nutrient concentration of nitrogen, phosphorus, or potassium, and the type of waste handling system, will dictate which fraction holds the highest concentration and the potential for recovery. Phosphorus within the solid manure and sludge tends to concentrate in the solid fraction, and in the liquid system, also referred to as lagoons, 50 to 85% of the phosphorus settles to the bottom as sludge. Organic nitrogen also tends to accumulate in the solids, behaving as a concentrated nutrient discharge. Nutrient recovery is a sustainable wastewater treatment process that removes phosphorus and nitrogen from waste streams, such as sewage or anaerobic digestate, and converts them into usable fertilizers, rather than disposing of them. This procedure typically involves a three-step pathway, involving the accumulation or concentrating of the nutrients, the release, which transfers them to a liquid phase, and then extraction or recovery, for precipitation or separation. Struvite precipitation is conducted in a dedicated reactor, where the liquid stream is treated to precipitate magnesium ammonium phosphate. Magnesium ammonium phosphate hexahydrate, with the complex chemical formula of MgNH4PO46H2O, is commonly referred to as MAP, or struvite. MAP poses a significant operational problem in wastewater treatment plants, as it forms hard scale in pipes, pumps, and anaerobic digesters. Managed treatment, by inducing a controlled precipitation process, solves the problem of uncontrolled struvite formation in wastewater treatment plants. Struvite is a phosphate mineral that often forms as white, yellowish, or brownish-white crystals. In industrial and environmental contexts, it is commonly recovered from wastewater, manure, or sewage, as a valuable slow-release, high-purity fertilizer in the form of granules or prills. These common NPK fertilizers are desirable since they are rich in nitrogen, phosphorus, and potassium. Meanwhile, potassium, with a chemical symbol K, generally tends to stay in the wastewater, rather than precipitating when conventional struvite is formed. Potassium may be recovered from the water column, in sequence along with all of the other mineral salts. Now, let's briefly review the recovery and management of the nutrient residues. All plant and animal matter contains nutrients as basic elemental building blocks of life. Residual nutrients accumulate in organic wastes, anaerobic digestion sludges, brines, and wastewater treatment facilities. One method of treating these sludges, or bioresiduals, is through the harvesting process in an attempt to remove the residual nutrient materials prior to discharge. Phosphorus recovery. Phosphorus and phosphate recovery efforts are largely driven as a result of the tightening of regulations that restrict the discharge of phosphorus from wastewater treatment facilities into waterways in the open environment. The continuous release of phosphorus into the water ecosystem results in a concentrated buildup of high levels of phosphorus, which may promote the growth of algae blooms, which produce algal toxins that can be harmful to both human and animal health. Various methods of phosphorus recovery are currently employed or being explored. One such treatment approach uses the controlled growth of algae, at the point of origin, to reduce phosphorus discharge. Other efforts are focused on the production of value-added streams, such as ferrophosphorus and industrial phosphates, as well as fertilizers and soil amendment materials. Nitrogen reclamation. The concentration of nitrogen in organic wastes, sludges and bioresiduals, provides the opportunity for nitrogen reclamation. Management systems for manure and animal waste allow for the control of concentration levels of elements, such as nitrogen and other accumulated nutrients. Potassium waste. There are a number of common sources of potassium wastes. These may include potassium oxide, K2O, contained in residual nutrient streams, and may also be found as a content in certain residual aluminosilicate materials. The recovery and use of hydroxide materials, such as KOH, may play a key role in an exothermic energy generation strategy, and may act as an absorbent to assist in the capture of CO2. Residuals management. The consolidation of trace elements, from waste stream residues and sludges, is the natural flow point for the opportunity for the concentration and recovery of inorganic minerals, nutrients, and heavy metals. The potential exists to capture values from late-stage waste streams, such as residues and sludges, or solid recovered fuel, SRF, as feedstocks for the elemental thermal disposition in a biorefinery. We intend to explore other types of the minerals recovery sector at some point in the future. Until then, please feel free to reach out to us at your convenience. Waste.net provides a neutral platform to assist in finding a market for scrap, waste and byproducts, with the goal of matching waste material generators directly with beneficial users of those materials. By connecting market participants, we foster collaboration and promote environmental sustainability. Please feel free to visit us today at www.waste.net.